Which relation is a function? So a relation is a bunch of x and y's. So looking at our option choices here, we see a bunch of x and y's. We could say that x equals 1 is related to y equals 3. They're paired together, so we say they're related. And a relation becomes a function when each x is associated with one y. So looking at our first option, let's take a look at all of the x's. We have -1, which is associated with 3. We have 0, which is associated with 0. And we see that -2 is associated with two different numbers, 6 and -2. So this is a relation. We can say -2 is related to 6. -2 is also related to -2, but it's not a function because -2 is related to more than one y value. So we can mark this off. That is not a function. Looking at option B, -2 is associated with -2. 0 is associated with 0. 1 is associated with 1. And 2 is associated with 2. So each x is associated with one y. So this would be our option. Let's take a look at the other options just to make sure we understand them. Option C, we can see that x equals 4 is associated with 4 different y values. We could say 4 is related to 0, 1, 2, and 3. Those are the y values. But we don't have a function here because our x, which is 4, is associated with more than one y. Think about our vending machine example from our lesson on functions. In a vending machine, you type in a number and you get out an item. So each number you type in is associated with one item. So that's how these numbers should work. You should put in a 4 into the vending machine and you should get out one item. However, when you put in a 4 here, you could get a 0 or a 1 or a 2 or a 3. So this is not a function. It doesn't act like a vending machine. So let's take a look at our last option. You put in a 7 into the vending machine and you get out a 4. You put in an 8 in the vending machine, you get out an 8. However, if you put a 10 into the vending machine, you get an 8 and a 10 back. That means your vending machine is broken. So our relation here does not act like a vending machine because our x equals 10 is associated with more than one y. Which relation is a function? So this is the same as the previous problem, it just looks a little different. Instead of pairs of numbers, we have a table. So we have our inputs, which would be the x values, and then our outputs, which would be the y values. So we just need to check, is each x associated with one y? So looking at our first option, 1 is associated with 2, 2 is associated with 2, 3 is associated with 3, and 4 is associated with 3. So each of our x values is associated with one y. It works like a vending machine. Each of those inputs you put into the vending machine, you will get back one output. So this would be our answer. Taking a look at option B, we can see that our x equals 2 is associated with a 6 or a 5. So you put 2 into the vending machine, and you get 2 options back. So we could say this is not a function, or you could just say this is not a vending machine. This does not work like a vending machine. And that can help you cross it out. Looking at option C, you can notice our 4 shows up twice here, and that's associated with a 6 and an 8. So this is not a vending machine. And similarly, D, a 0 is associated with 2 values, and a 1 is associated with 2 values. So we don't have a function. What is the domain of the function shown on the graph below? So domain would be the possible x values. So taking a look at our graph, we have 4 points here, And the first point has an x value of 1, second point has an x value of 2, the third point has an x value of 4, and our final point has an x value of 5. So we can say that our possible x values are 1, 2, 4, and 5. And looking at our options, that would be option D. Another important word to know is range. Domain is the possible x values, and range is the possible y values. So looking at our graph, our first point has a y value of -4. Our second point has a y value of -5. Third point has a y value -1. And our fourth point has a y value of -2. So writing those in order, we have -1, -2, -4, and -5. And you might notice that that is option B. If the question asked for the range of the function, we would have selected option B. Which of the following graphs represents a relation that is not a function of x? So we want to find which is not a function. So a function is when each x is associated with one y. So we can mark some x's along each graph and see how the y's behave. On our first graph, our first x is associated with one y. Our next one is associated with one y. And so are the other two. So it looks like each x here is associated with one y, so this would be a function. So let's mark it as function. Our second graph, our first x is associated with one y, our second x, and our third, and our fourth are all associated with one y. So it looks like this is a function. Looking at our third graph, this x is associated with one y, and our next one, and our next one. So this would also be a function. In our last graph, our x is associated with two y's. You put in something into the vending machine, and you would get two things back. So we've proven that this is not a function, because we found an x that is associated with more than one y. So our question said, which is not a function? D is not a function.